Hello everyone, welcome to the kinematics and dynamics of machinery class. In this video, we're going to continue the cam design topic for this course, and we're going to focus on the graphical representation of the displacement diagram of the follower's motion. We discussed in the previous video that we have three different events for the follower motion. That follower would exhibit some rise and then dowel, then return back again. There would be one more time dowel period for the follower motion during the complete cycle of rotation of the cam. That the cam rotates, just exhibits rotational motion. So there is a specific angle of rotation of the cam motion in which the follower is going to rise. Then there is a specific period of the cam rotation in which the follower would dowel. Then there is another period that for which the follower is going to return. But while it rise or return, it would rise or return following a specific different types of the follower motion that we already discussed the previous meeting. We would have it would rise or return with uniform velocity or uniform acceleration or simple harmonic motion or cycloidal motion or the modified uniform velocity motion. So what I'm gonna do here in this video, I'm gonna show you how we can represent the displacement diagram of the follower motion and graphically represent these different types of the follower motion that we discussed on the previous video, right? So basically, to work graphically, we have to specify a scale for our drawing. And basically, we do have some scale for the, because in the displacement diagram, it would include over the horizontal axis, the theta axis, and we do have the vertical axis, which is the y-axis, that represent the lift or the rise or the return or the displacement in general of the follower. So that's why we have to specify a certain scale by which we are going to draw the displacement diagram. It is recommended to have a scale like 30 degrees, each 30 degrees of the cam rotation, because we have two axes, so we have we should set up two scales for the two axes, for the y and the theta axis. The y-axis, it depends on the size of the cam, and the maximum displacement and the minimum displacement definitely of the follower should be 0. I'm talking about the maximum displacement, how much it is, and it depends on the drawing sheet that you're gonna use for the graphing or represent the graph of the displacement diagram. So it would be varying from one problem to the other one, but the theta axis basically changes from 0 to 360 degrees. So a perfect scale actually is just to assume any 30 degrees, each 30 degrees of rotation of the cam, it is equivalent into my drawing scale to 1 centimeter of drawing scale. Right? You can assume this thing, you can assume other thing, but based on my experience, this is a perfect scale that you could consider that represent every 30 degrees of the cam rotation. It is equivalent in my drawing, in my graph of the displacement diagram, into 1 centimeter over the theta axis. I can assume this thing, you can assume 2 centimeters, you can assume more than that, it's up to you. But basically, this is based on my experience, this is a perfect scale to assume. And then the next step is just once you set up and know exactly what scale that you're gonna use, you have to set up or break down the entire displacement diagram into the rise period, the dowel period, and the return period, as already explained to you in the given problem. So for example, let us assume that the follower is going to rise for 180 degrees of the cam rotation, So this is the first event. This is, you could say that this is event 1. This is the first event. And then the second event, that the follower, it should be dowel for 60 degrees of the cam rotation, Then the third event is going to return for the rest of the cam rotation. Like the rest is gonna be like if you just add 160 plus the 160 negative the 360, so we still have only 120 degrees of the cam rotation that it should be representing the return of the follower. So this is the 360. If you just sum all of these angles, this is 360. But if we would break down even the 120, it would return in just 90 degrees, and there is another 30 degrees of another dowel at the end of the first cycle. Then the cycle of the cam rotation is going to rotate. So it means that these are the different events you have to break down. You have to know exactly these events will be described to you into the given problem. But your objective is just to acknowledge them, to distinguish between them, how it's going to rise for how long in terms of the cam rotation, the dowel period, the same thing for the return period, how long these periods are. Then your objective is just to break down the displacement diagram. So you're gonna set up the y-axis here. This is gonna be the y-axis, and this is gonna be the theta axis for the displacement diagram. And remember that theta changes from 0 up to 360 degrees, right? And according to the scale that we assume for the theta axis, this is for theta axis, by the way, that every 30 degrees of the cam rotation is equivalent to 1 centimeter. So according to the scale that we just assumed here, according to this scale, the 180 degrees of the cam rotation, it is equivalent to how much of centimeters over the theta axis? If you divided 180, if you divide, just do this simple calculation, 180 divided by the 30, which is your digit, it should equal to how much, it's going to give you directly the centimeter. Over 30 is going to give us 6 centimeter. So it means that the 180 degrees, which during the rise period, it should be represented over the displacement diagram at the lengths here, it should equal to the 6 centimeter. So you're going to measure 6 centimeter from the 0 point and measure 6 centimeter. Let's say it became here. This is like the length, this length, it should be the 6 centimeter. And we're going to call this period as beta. Beta, this stands for the rise period or beta for the rise period. This is the angle of rotation or the period of rotation of the cam that would need it to give rise to the follower. So this is like beta rise or just beta. And remember that we do have here a total lift. So we should have here, like, assume that this is the total lift and this lift period also, or length. This is the maximum displacement of the follower. It will be provided or given to us, right? So we're gonna end up, then you're gonna mark here, like draw a very small dash, this dash rectangular shape, just to define the area of the rise. This is gonna be the rise period. Then what is going to dowel for just 60 degrees. So 60 degrees, it means that if you divided 60 degrees by 30 degrees, this is gonna give us just 2 centimeter. So it means that you're just gonna measure another 2 centimeter and mark a point. This is gonna give us this period, it should be the dowel period. Then your objective is just to draw another rectangular shape for this second period. This is gonna be the dowel period. Make sense? Then it's going to return for the rest of the rotation for the 120 degrees of rotation. If you divided the 120 degrees over 30 degrees, this is going to give us 4 centimeter. It means that for the other 4 centimeter, because they enter the 360, if you divide by 30 degrees, this is going to give us 12 centimeter. So we already used 6 centimeter and 2, so we still have only 4 centimeter of return. And this is going to be the beta, but for the return period. This is another beta for the return. This is beta for the dowel period. So these are the different betas. We can say that this is beta for rise, beta for the dowel period, and we do have beta for the return period. Make sense? In addition to the total lift or the maximum displacement of the follower as already given to us, this L value, the lift value will be given to you in the problem, right? So this definitely is going to give us the return period. So this is the like initial setup of the displacement diagram. You have to acknowledge, you have to know the different events and how long these events will be done in terms of the cam rotation, in terms of the angles, and you're going to assume a scale and you try to break down the displacement diagram. So your objective is just to represent the rise of the follower and the return of the follower depending on the different types of the follower motion that we already described or discussed in the previous meeting. But here in this video, I'm going to show you how we can represent these different types of the follower motion graphically during the rise period, during the return period. Something that you should understand about the Dual period, the dual period is just stationary, that the follower is just stationary, so there is no displacement. It means that the displacement function, the displacement function of the follower is going to be constant function. It means that this indicates that there is no change in the velocity, there is no change in the acceleration. This indicates that the follower should be stationary during this period of the cam rotation. So the dual period, all the time it should be represented by a horizontal line. But how about the rise period and the return period? How is going to rise and return? This depends on the different types of motion that we discussed for the follower in the previous video. Here I'm going to show you how we can represent these different types of the follower motion graphically, starting with the uniform motion. So let us start here with the first type, which is the uniform motion. So number one here, the uniform velocity motion. Uniform velocity motion, as we mentioned in the previous video, that it means that the follower is going to rise or even return with a constant velocity. And for that reason, the displacement, it should be a linear function, that y it should be varying as a linear function, as a function of theta, as we represented in the previous video. So how we can represent this uniform motion is going to be very simple. So what I'm going to do, I'm just going to copy this diagram. You have to do the breakdown again. Very similar, the rise, the dual, and the return. So I'm going to copy this diagram, then I'm going to show you how we can do the uniform motion, velocity motion analysis graphically. All right, so for the uniform velocity motion, if this is the breakdown, and let us assume that the riser is going to rise, the follower is going to rise with like with a uniform velocity motion, and is going to return with the same type of motion within the rise period and the return period. So the uniform motion, it means that we should start from here. This is going to be our start point. You have to define this point. This is going to be the start for the rise period, and then it's going to dual. This is going to be the start point for the return. So you have to look at the start points for the rise period and the return period, because definitely it's going to rise, then dual, then it's going to return again, starting from this corner. So as you can see, the rise period, it has like a rectangular area. Once we define this rectangular area or zone, you can simply, starting from the start point, you're just gonna connect the other corner. This is one corner, and this is gonna be the other ending corner. If you just connect these 2 points together, this is gonna give us the uniform motion. This should be linear function, straight line. Connecting these 2 corners together, this is gonna give us the uniform velocity motion, how it looks like in the displacement diagram during the rise period. Then we're gonna have dual period, then it's going to return starting from this point to the other corner. So your objective is just to connect these 2 points together. You're gonna end up automatically with the uniform velocity motion within the return period. Make sense? So this is how we can graphically represent the uniform velocity motion during the rise and the return period. Again, it is very simple. This is the simplest type of motion that you would have for the follower motion during the rise and return period. Make sense? Now let us move to the next type of motion, which is the parabolic, that would include constant acceleration or motion, which is the parabolic motion. So this is the second type here, which is the parabolic motion. So we're gonna do the same. We're just gonna do the same breakdown as we represented here for the uniform motion or the displacement diagram. We're gonna break it down into 3 periods or 3 events: rise, dual, and return, as we already did here. So I'm just gonna copy this figure, So the parabolic motion, as we discussed in the previous video, it means that their follower is going to rise and return with constant acceleration, right? And based on what we discussed in the previous video, I'm going to show you how we can represent the displacement diagram of the during the rise and the return of the follower motion based on a constant acceleration, right? Following this parabolic motion analysis. So the process starts that you have to divide the beta and lift this beta axis or this horizontal line and this vertical line or the vertical line into equal number of segments. and these segments should be identical with the same length. Let us start with the beta, and you can divide it into like 4 or 5 or 6 or 7. As much as you increase the number of segments, this definitely is going to increase the accuracy of your graph, of your representation. So you could say that the number of digits, it shouldn't be less than 4, because less than 4, it means that it is gonna be very rough and discretized curve, and the representation, it won't gonna be accurate as long as we gonna use the same graph again for the to come up with the cam profile. So the key idea here is just to break down into a certain number of segments that make sense, and for this case 6 digits is a very good number. Like 4 or 5 or 6 digits is a very good number. And for the parabolic motion that we already discussed the previous meeting, it is recommended to have even, or you could say that it is it is better to have an even number of digits. Like let us assume that we're gonna break this one into 6 digits. As long as this angle is 180 degrees, if you divided 180 divided by 6, this is gonna give us 30 degrees. And according to our scale that we introduced up there, the 30 degrees is gonna be represented as 1 centimeter. It means that you're just gonna break down the 6 centimeters for the beta into 1 centimeter segment. So you're gonna start from 0. Why we start from here? Because we're gonna start the rise motion from this point, then we're gonna go up till the dowel, then this is gonna be the start point for the return, as we discussed with the uniform motion. So starting with the 0, then you're gonna measure 1 centimeter and put a mark, another mark, third one, fourth and fifth and the sixth. So this is gonna give us 1 and 2, 3, 4, 5 and 6. Make sense? Then you just gonna pick the mark in the middle. The middle mark, this middle mark would have one segment, second, third, or 1, 2, 1, the 3 marks, and there is another 3. So this is gonna be this mark number 3 is the middle one. Then from this one, you're just gonna draw a vertical line, dash line. This line, it should be broken down into the same number of segments that you divided here. You're gonna break it down into the same number of segments, 6 segments. So we're gonna do the same as we did here. Starting from here, this is gonna be the start point 0 dash. Why this one is 0 dash? Because this is our start. We start from here, then we're gonna go up. We start from and we go up. Make sense? So this is gonna be the 0. Then you're gonna have 1 mark, the second, the third, the fourth, the fifth and the sixth. So why this 0 again? Because we are doing rise. So the forward motion starts from 0 and it's going to increase. It's going to move in this direction. This is going to be the 1 dash, then 2 dash, 3 dash, 4 dash, 5 dash, and the 6th dash, the same number of digits that you divided before. Make sense? Then your objective is just to start. Locate the start point and the end point. What is the start point? This is going to be the start point. This is going to be the start. And this is going to be the end point of the rise, because it should start from here and then rise up to the other point. Make sense? Then also you can mark one essential point, which is this point in the middle, but it is not essential for now to do so. But your objective is just to connect the start point to the 0, 1, 0 dash, 1 dash, and 2 dash, and 3 dash. Then you're gonna connect the end point with the 6 dash, 5 dash, 4 dash. So we're gonna connect the start point. You're just gonna connect the start point. Let me use this color. This start point with the 0 dash, and the start point with the 1 dash. The start point with the 2 dash, the start point with the 3 dash. Make sense? So the first 3 or 4 marks will be connected to the start point, and the starting from 3 dash also you're gonna connect to the end point. The other points starting including the 3 dash. Why 3 dash? Because the 3 line is the middle dash. This is the middle mark. So you're just gonna connect this middle mark to the end. If your drawing is accurate, this line, it should be straight line all the way from the end to the start. The same thing, the end point will be connected to the 4 dash, the endpoint will be connected to the 5 dash, endpoint will be connected to the 6 dash. So we're just gonna connect the end and the start point with the point on the top, because these points are the closer one to the end, these points are the closer one to the start. Then what you're gonna do, you're just gonna draw vertical lines from all of these horizontal marks. So you're gonna draw horizontal line from the 0 mark, vertical line from the 1 mark, vertical line from the 2 mark, vertical line, we already have it, from the 3rd mark, and vertical lines in this way. Make sense? So we're gonna end up with some intersections. Your objective is just to locate these intersection points. Like, for example, the 0 dash, the line, the green line for the 0 dash is going to intersect with the vertical line of the 0 at this start point. So this is the first mark, the first point. Also, the 1 dash is going to intersect with the 1 line with another mark. The 2 dash is going to intersect with the 2 with a mark. 3 is going to intersect with the 3 at the same mark, at the same point. So this all the time point is a common point between the two periods, right? And the same thing, now we're gonna move to the other lines. Like this line is the 3 dash is going to intersect with the 3 in the same point. The 4 dash line is going to intersect with the 4. This is the 4, this is the 4 dash in a point. The 5 is going to intersect with the 5 dash in a point. The 6th is going to intersect with the 6 dash in a point. This is the 6 dash line, and this is the 6th line. Both they're gonna intersect in a point. Then your objective is just to connect these points by hand. And we're gonna end up with the curve for the parabolic motion that describe the parabolic motion. It's gonna have like kind of acceleration, then it's gonna be followed with kind of deceleration to end up with to move to the dual motion. So this is the follower motion during the rise period. It has acceleration, then there is deceleration. So there is kind of acceleration within this period, then we do have like kind of deceleration. But the value of the acceleration and the deceleration as a value, they are the same. But here the acceleration is positive, here it should be negative. And this makes sense. We are going to increase the velocity to be maximum in the middle, as we discussed in the previous meeting. Then it's going to decrease again till the dowel. Then it's going to be fixed to 0. It's going to return to 0 velocity. Then it's going to be stationary. Then we're going to start the return motion again, right? So I'm going to repeat what we did here for the rise motion with the return motion, typically the same. Make sense? So in general, in the return motion, we basically start from that point. We start from this point here, right? We start from this point, which is this one. Make sense? So we're gonna divide the beta axis into 6 digits. You can use 6 or 4 or any even number. So we said that 4 or 6 is quite good. So I can break it down into just 4, or you can use 6 digits. Is gonna be more accurate representation if you wish. So starting from here, why we start from here? Because basically we're gonna start from here. So this is gonna be our 0 point. Then we're gonna divide it into 4 digits. So if this angle as given up to us, it is 120 degrees. So if you divided 120 by 4, this is gonna give us 30 degrees. It means that you're just gonna measure the 1 centimeter and another centimeter, the 3rd and the 4th. So this is gonna be mark 1, mark 2, mark 3, and mark number 4, right? So I divided into 4, so I'm gonna do the same for the middle line. This is gonna be the middle mark. You're just gonna draw a vertical line, dash line in this way, and then you're gonna break down this line into 4 marks as well. So we're gonna have like 1 mark, another mark, and 3rd mark, and this is gonna be the 4th. Make sure that the distances should be the same, the spacing should be the same, and we're gonna start from 0 dash. It should be here. Why there on the top? Because this one is going to return. Remember that we started 0 dash here because we are going to rise. Here we start from 0 dash because we are going to return. This is the return motion. So it is 0 dash, 1 dash, 2 dash, 3 dash, and the 4 dash. Make sense? Then you're just gonna connect, you're gonna start to connect the start and the end point. So you have to define where is locate the start point. This is our start point for the return motion, and this point is gonna be our end point for the return motion, right? So you're just gonna connect the start points with the nearest marks. We do have here, this is going to be the middle mark, right, which is 2. So you're just going to connect 0 dash to the 0, 1 dash to the 1, to the 0, to the start point, right? Then the 2 dash will be connected to the start point. This 2 dash, it is a common point. This is the middle point, so it should be connected to both the start and the end. So it will be connected to the end. The 3 dash will be connected to the end. The 4 dash will be connected to the end, right? Then you're just gonna draw vertical lines from these horizontal marks. Like the 0, you're gonna have vertical line. From the 1 mark, vertical line. From the 2 mark, we already have the vertical line, the 3 line, and the 4th line. Then we're gonna end up with some intersections. Your objective is just to locate this intersection. Like the 0 is going to 0 dash is going to intersect with the 0 at a point. So this is the first mark. Then the 1 dash is going to intersect with the 1 in a point, another mark. The 2 dash is going to intersect with the 2 in the same mark. And the 3 dash, this is the line for the 3 dash, is going to intersect with the 3 in a point. The 4 dash intersect with the 4 in a point. So we're gonna end up with set of points. If you try to connect them by hand, we shall end up with the curve for the parabolic curve for the return motion. So just connect them by hand, these marks. We're gonna end up with the displacement diagram within the return motion or return period. So it's going to rise with parabolic motion, then double for 60 degrees, then it's going to return for 120 degrees based on the parabolic motion as well as constant acceleration. So it's going to start with, because the velocity here it is 0, so it's going to start with acceleration. This period is going to be acceleration, then it's going to decelerate one more time back again to the 0. So the velocity will be starting 0, then it's going to increase to be maximum in the middle, then it's going to decrease again till 0 in the second half of the return period. Make sense? So this is how we can represent the follower displacement within the rise and the return based on case that the follower is already moving with a constant acceleration. Make sense? So now let us move to the simple harmonic motion. This is the third type of motion that we discussed during, and let us discuss how we can represent the simple harmonic motion of the follower during the rise and the return period. So again, what is going to be very similar to the thing that we did with the parabolic motion, but with a little bit some changes. Like the first step is just, as we discussed, we're going to start from here. So this is going to be our 0 point. Your objective is just to break down the beta axis into even number of digits. We said that either 4 or 6 is quite good. Like 6 digits is quite good as long as we have this period as 6 centimeters, for example. So we're gonna break it down into, like, this is gonna be the first mark, the second, the third, the fourth, the fifth, and the sixth. So this is gonna be 1, 2, 3, 4, 5, and 6, typically the same as we did with the parabolic motion. Then what you're gonna do from the middle of the left, because this vertical height, this vertical distance from this horizontal dash line to this vertical horizontal solid line, the theta axis, this height, it should be L, and this L should be given to us as we discussed before. So you're just gonna calculate L over 2, half the L, and you're gonna use the canvas to draw a circle. So from the middle of this y-axis, from the midpoint, you're just gonna mark a point. This is gonna be the center point, and you're gonna use the compass and fix with the metal tip here, the metal needle of the compass, and start to touch with the lead point of the compass at this point, and just draw a semicircle, half circle in this way. So if our measurements are accurate, the radius of this circle, again, the radius of this circle, it should be L over 2. This circle should have a radius. The radius of this circle, it should equal to the L over 2. L, this is the total left over 2. You're just gonna draw this semicircle. Then, what you're gonna do, you're just gonna divide this circle into even now the same number of segments that you already break down this beta axis. It is not necessary, by the way, to be the same number. No, it should be the same number. If this is 6, you have to break it down into 6 as well here. So this angle, this semicircle, its angle is 180 degrees. So if you divided 180 degree by 6, this is gonna give us 30 degrees. So what you're gonna do, you're just gonna use the protractor to measure an angle from this vertical line, because this is gonna be again the start point, because we are going to rise. So we're gonna divide this one. We're gonna put marks here starting from 0 dash, 1 dash, 2 dash, and so on, rising up, because this is rise, right? So we should start from down going up. Make sense? So this is gonna be the first mark. From that mark, you're just gonna measure another angle. This angle, it should be 30 degrees, because we are going to break it down into 6 digits or 6 segments of the circle. So we're gonna mark a point, or you're just gonna measure 30 degrees and measure a point and mark a point here, that this angle, it should be the 30 degrees. Then you're gonna mark a point, then you're gonna measure another 30 degrees and mark a point. So this is gonna be another point, and so on, keep going. One of the things, for example, if you just located the first 2 marks, if you located the first 2 marks, you can directly end up with the other 2 marks in this way. Like if you draw a vertical line from this point, going up is going to intersect with the circle in another mark. So this is gonna be 1 mark. This is 1 mark. This is the second. This is the third. This is one of the 6 marks. Then doing the same for this one, if you just draw a vertical line, this line is going to intersect with the circle in another mark, and definitely we're gonna have 1 mark in the middle here. This is because this angle is 30 degrees. This should be 30, this should be 30. Without measuring the 30 degrees one more time, you just can draw these vertical lines. You're gonna end up with the other marks. So at the end, we got 6 marks. 1, 2, this is gonna be 1 dash, this is gonna be 2 dash, this is gonna be 3 dash, and 4 dash, and 5 dash, and this 6 dash. Make sense? Then what you're gonna do, from these horizontal marks, you're gonna draw vertical lines. So we're gonna draw some vertical lines. So from the 0, we're gonna have a line. From the 1, we're gonna have a vertical line. Make sure that it is vertical. And from the 2, we're gonna have a vertical line. From the 3, we're gonna have a vertical line, and so on. Make sense? Once we finish this vertical line, you're just gonna draw from all of these marks horizontal lines. So there should be, let me use another color. So this is the 5 dash horizontal line. From 1 dash, I'm gonna draw a horizontal line. From the 2 dash, another horizontal line, and so on. 4 dash, and the 5 dash, and there is the 6th dash. We're gonna end up with some intersections, right? So we're gonna locate the intersection points. Like this is the 0 line with the 0 dash line. They're gonna intersect at the start point. This is our start point anyway. This is gonna be 1 mark. Then we're gonna have the line 1 with the line 1 dash. They're gonna intersect in a point. Line 2 with the 2 dash. They're gonna intersect in a point. 3 with the 3 dash. 4 with the 4 dash. 5 with the 5 dash. And the 6 with the 6 dash. So we're gonna end up with these marks. Then your objective is just to connect them by hand. So this is gonna give us definitely the curve for this is gonna be the curve for the simple harmonic motion during the rise period of the follower. It's gonna be in this way. Make sense? How about the dowel? This is just dowel. Beyond the dowel, we do have the return. And again, we're gonna start from this point. This is gonna be our start point. So we're gonna repeat the same thing, the same procedure, but for the return. But instead of drawing the circle on the right, on the left, we're gonna draw the circle on the right here for the return period. And we're gonna start from that point. So this is gonna be our 0 point. And again, you're gonna break the return period into either 4 or 6 digits. It's up to you. Let us break it down into 4 digits as long as this one is already 120. So if you divide 120 divided by 4, this is gonna give us 30 degrees. So we're gonna break it down into 1 centimeter and 2, 3, and the 4th. So this is the Mark 1, Mark 2, and Mark 3, and Mark 4, typically the same as we did with the parabolic motion. And here we have to draw a semicircle. This semicircle, it should be its center point. It should be at the middle of this vertical line. And you're gonna fix with the middle tip here and touch with the lead tip on this point. Then you're gonna draw the semicircle. If it is accurate, try to be more accurate, to be accurate as much as you can in terms of the drawing. I know. Okay, so we got the semicircle. Then your objective is just to break it down into the same number of digits that you already divided the beta axis to. So we divided 4, so we have to break it down into 4. So this semicircular is 180 degrees divided by 4. This is gonna give us 45 degrees each segment. It means that you're just gonna measure, and we're gonna start again from this point, 0 dash. 0 dash, why it is on the top, like it is not down like this one, because we're gonna move down. So we start from here going down. So this should be like 0 dash, 1 dash, and so on. So if you measure 45 degrees, then you're gonna end up with a mark. So this is gonna be the second mark, 1 dash, while this angle it should be 45 degrees because we divided it into 4 digits. So this is gonna give us the second mark. The third mark, if you just, again, if you can do the same procedure, you can do the same technique, that draw a vertical line from this mark. If you draw a vertical line, you're gonna end up with the mark that should be here at 45 degree. Then your objective is just to mark here like 3 dash. This is gonna be the 4 dash. Make sense? Then what you're gonna do, your objective is just to draw vertical lines. We're gonna draw vertical lines from the 0, vertical line from the 1, and so on, in this way. And from these marks over the circle, you're just gonna draw horizontal lines. So this is one horizontal line from 1 dash, and the 2 dash, the 3 dash, and the 4 dash. Make sense? So we're gonna end up with some intersections. The intersection of the 0 dash with the 0, this is gonna give us 1 point, and again, this is our start point for the return motion. This should be one of the marks. Then the 1 dash with the 1, this is gonna give us point. The 2 dash with the 2 gonna give us point. The 3 with the 3 dash, and the 4 with the 4 dash. We're gonna end up with this line. Then your objective is just to connect them with by hand to end up with the simple harmonic motion during the return cycle, how it looks like. It's gonna be in this way. So this is gonna be the simple harmonic motion in the rise, and this is the simple harmonic motion but during the return period. Make sense? So the cycloidal motion is the fourth type of motion that we are going to discuss here. We discussed the uniform velocity and the parabolic in addition to the simple harmonic motion. This is the fourth one, which is the cycloidal motion. In the cycloidal motion, we're just gonna follow the same procedure. We're gonna break down and define the rectangular area for the rise period and the return period, the same thing for the downward period. So this is rise. We're gonna break down the beta axis into an even number, 6 digits. It should be 6 digits all the time for the cycloidal motion. But for the simple harmonic motion or the other types of motion, you can break it down into any even number like 4 or even. It shouldn't be even, it would be odd number like 5 or 7. It depends on the type of motion, but for this cycloidal motion it should be split into 6 digits. So the 6 is a crucial number, and I'm gonna let you know why. So we're gonna divide here beta into 6 digits starting from the 0, as long as this is 6 centimeters, so it's gonna be, the distance is gonna be 1 centimeter, so it's gonna be just 0 and 1. We're gonna have here the second, the third, the fourth, the fifth, and the sixth. So this is gonna be 2, 3, 4, 5, and 6. So these are the 6 digits. Then what your objective is just to draw, to locate the start point. Again, this is our start point for the rise period, right? And this is gonna be the end point for the rise period. This is gonna be the end point. So at the end point, your objective is just to draw, at this end point, is just to draw a circle. The radius of this circle, it should equal to L over 2 pi. So again, at the end point, once you break down these segments and define these marks, at the end point of the rise period, you're just gonna draw a circle. The radius of this circle, it should equal to L over 2. So we're gonna use a radius here. The radius of this circle, it should equal to L over 2 pi. Make sense? So what you're gonna do, you're just gonna draw a circle, a little bit small circle. Just calculate this value. This L, it should be the total left, if you remember, right? This should be L. This L divided by 2 pi, this is gonna give us a radius, a value. Open the camps with this value of the radius, you're gonna end up directly with the circle and draw the circle, its center point, it should be this end point. So we're gonna end up with a circle in this way. Make sense? Then what? Your objective is just to break down this circle into 6 digits or into 6 segments. So the complete circle is 360 degrees divided by 6 segments. This is gonna give us each segment should be 6 degrees, 60 degrees. Starting, so how we can measure the 60 degrees? Starting from the horizontal axis, this horizontal line, you're just gonna measure an angle to the top with 60 and another angle down with 60. You're gonna use the protractor to measure these angles. Then you're gonna mark a point and you're gonna mark a point and the 60 on the top, 60 down. Then this point will be just gonna draw a line and draw another line. Make sense? And as you can see, do you see this? So we're gonna end up with like this angle. It should be, yeah. So this angle we already have here. This is gonna be also, we do have this horizontal line because we already have this line at 60. Just measure 60. This is gonna be one of, this horizontal line is an essential line. This is the start line. This is gonna give us like 2 segments, like 2 marks. 1 mark here, 1 mark there, right? Then you're just gonna measure 60 on the top, 60 down, and mark other points and connect this point, this line, and draw another line in this way at the 60 degrees. So we're gonna end up with some marks. Let us put this mark starting from, since we're already working as rise, it means that we have to rise up. We have to move up. So we're gonna start from the 1 mark. This is gonna be the mark number 1. It should be here. Then we're gonna rotate in the clockwise direction. This is gonna be the clockwise direction. It means that this is gonna be 1, and this is gonna be the second mark, mark 2, and this is gonna be the third mark. Right? This is gonna be the third mark, and this is gonna be the fourth mark, and this is gonna be the fifth, and this is gonna be the 6th mark. You got my point? If your drawing is accurate, this angle, this a little bit angle, it should be 30 degrees. If our drawing is accurate, this angle, it should be 30 degrees, and this angle, it should be 30 degrees. As long as you measure 60 degrees, this is gonna be 60. It means that this entire angle, it should be 60. This it should be 60, this it should be 60, 60, and so on. So we're already dividing, even this is gonna be 60 degrees, and this is gonna be 30 degrees. 60, I'm sorry, this is gonna be also 60 degrees, okay? But this angle with the vertical axis, this is one is gonna be 30, and this is gonna be 30. So you just gonna do as typically, as I said, you just gonna draw a horizontal line, measure 60 degree down, measure another 60 degree on the top, put 2 marks, and then draw a line at the 60 degree to just connect this mark to the center point and connect this mark to the center point. You're gonna end up with another line, so you are in a good shape. 3 lines that you're gonna have, horizontal one and these 2 crossed line. Then you're just gonna put marks over the circumference of the circle. Starting from 1, it should be down the right lower corner for the rise period, the right lower corner, and rotate the clockwise in the clockwise direction. You're gonna end up with 1, 2, 3, 4, 5, and 6. Make sense? Then what you just gonna do, you're just gonna draw a horizontal line. You're just gonna connect point 1 and 2 with horizontal line. If your drawing is accurate, this line, it will be exactly horizontal. Then you're gonna connect point or mark 6 with 3 and with horizontal line, and 5 and 6 and 4 with horizontal lines. So we're gonna end up with 4 horizontal lines. Make sense? So again, you're just gonna draw the circle, both marks, and draw these cross lines. Then you're just gonna look at these points. Then you're just gonna draw a horizontal line connecting 1 to 2, and horizontal line connecting 3 to 6, and horizontal line connecting 5 to 4. Then you're just gonna locate. So this is for the circles. Forget about the circle for now. Now you're just gonna draw a vertical lines from these marks. Like from the 0, you're just gonna draw a vertical line as usual. And from 1, you're gonna draw vertical line. From 2, vertical line. 3, and so on. Make sense? Then what? Your objective is just to locate the midpoints of these horizontal segments. I connected 1 to 2, right? So just locate the midpoint, which it should be with the vertical axis, the intersection of this horizontal line with the vertical axis. This is going to give us the midpoint of this segment 1, 2, right? Then your objective is just to draw, or the same, you're going to do the same for the segment 3 and 6. For the segment 3 and 6, you're just going to look at the midpoint, which is definitely is going to be the center point of the circle, and the midpoint of the segment 4 and 5. Then what? Starting from the midpoint, this midpoint in the segment 3 and 6, you're just going to connect it to the start point, which is the 0 point. So just connect this point to this point, to the 0 point. This is going to give us the first line. We need other 2 lines that should be exactly parallel to this middle line. So we're going to start from the midpoint of the segment 3, 6, and we're going to connect this midpoint to the 0 point. This is going to give us the first line. We're going to do the same for the segment 4, 5 and the segment 1, 2. So we're going to connect the midpoint of the segment 4, 5. We just gonna draw a line. We won't gonna connect it to anything except just drawing a line that typically parallel. So you have to use the Aristo triangle to make sure that this line is parallel, that exactly parallel to this first line that we draw. So that's why this line in the middle, this middle line, it should be the first one to be drawn, because we're gonna use this one as a reference to be parallel to the other line. The same thing for the segment 1, 2, from the midpoint, we're just gonna draw a line that should be typically parallel to the middle line. You should understand that this line is not connected to 1. No, this line is parallel to the middle line. This line on the top is parallel to the middle line. Make sense? So that's why we have to start with this line in the middle first, connecting this midpoint to the start point. This is, or the end point of the rise period to the start point of the rise period. You're just gonna connect them, which definitely should be the center point of the circle, and you're just gonna draw from this midpoint of this segment 1, 2, you're gonna draw a line. From the midpoint of this segment 4 and 5, you're gonna draw another parallel line to the middle line. Make sense? Then we're gonna end up with some intersections. Your objective is just to locate these intersection points. So for example, starting with the segment 1 and 2, this line belongs to these to marks 1 and 2, because it is set up between or is projected from this midpoint of this segment 1 and 2. So the intersection of this line with the one line, with the one mark, with the vertical line of the of mark 1 and the vertical line of mark 2, this is going to give us 2 points. Definitely the start point is one of the points. So we do have 1 point here, we do have another point, we do have another point. Why these 2 points? Because this line, it belongs for the segment 1, 2, and they do intersect with the vertical line 1 and 2. Make sense? Do the same. This line, it is for 3 and 6, because it is set up between 3 and 6. So this line, it is for 3 and 6. So the intersection of this line with the 3 gonna give us point. The intersection of this line with the 6 is gonna give us another point, which it should be the center point. This line, it is for the 5 and 6, the 4 and 5. So its intersection with 4, it should give us point, and its intersection with 5, it should give us point. If my drawing is accurate, this point, it should be located within the rise zone. It shouldn't be up. As you can see, the intersection of 5 with this line, it is already up. Because I'm not using a scale, I'm just doing freehand sketching, but if you're accurate, it is if your drawing is accurate and you're already using the tool, this point, it should be located within the zone of the rise period, right? So we're gonna end up with some marks. Your objective is just to connect them by hand to end up with the cycloidal motion within the rise period. In this way. Excuse me. Make sense? So this is the cycloidal motion during the rise period. Let us repeat again to the return period. Remember that the 6th digit is crucial thing for the cycloidal motion. We have to break it down into 6 digits or segments. So we're gonna do the same. Going to the return, we're gonna start from this point for the return motion. So this is gonna be the 0 mark. And now we have to break it down into 6. This period, it is 120 degrees. If you divide it by 6, this is gonna give us 20 degrees. So 20 degrees, if you scale it up, if you scale it down into, with respect to the 30, so the 20 divided by 30, this is gonna give us two-thirds of the 1 centimeter, which is gonna be like 0.67. It means that the segment, it should be 0.67 centimeter, which is gonna be like 6 millimeter, 0.7 millimeter. So if you got it like 6.5, or just put any mark between the 6 and this, the dash or the mark of the 6 millimeter and the 7th millimeter, just put any mark in the middle. The accuracy will not be that high, but it is acceptable because we have to break it down into 6 segments. So I'm just gonna start with the 0, then you're just gonna have 1 mark, 2nd mark, 3rd mark, 4th, and the 5th and the 6th. So this is gonna give us mark 1, 2, 3, 4, 5, and 6. Make sense? So since this is the start point, the end point of the return motion is going to be this one. So this is going to be the center of this circle. And again, the radius of this circle, it should equal to L over 2 pi. So you're just going to calculate L, which is already given to us, divided by 2 pi. You're going to end up with a value. Open the comes with this value, you're just going to draw a circle. So we're going to draw a circle here. The radius of this circle, it should equal to the L2 pi as we discussed. Make sense? Then we're going to repeat the same thing that we did before. We're just gonna start by drawing a horizontal line from the center point. Draw a horizontal line. Draw a horizontal line. This is gonna be the first line. So we're gonna end up with 1 mark, and this is the second mark. This is gonna be like 3 and 6 marks. Then you're just gonna measure 60 degrees on the top and down. Blue, you're just gonna measure another 60 degrees. So we're gonna end up with, with a mark, if you connected this mark to the center point, we're gonna end up with a line, and you're gonna end up with another mark on the top, and just connect to the center point, you're gonna end up with another line. So we're gonna end up with 6 marks as already given here, right? So remember, in this rise period, we started from the right lower corner 1, and we rotated clockwise direction. So we're gonna do typically the opposite to these things, but instead of starting from the right lower corner, we're gonna start from the right top corner. This one, this is gonna be our first mark. Then we're gonna go in the counterclockwise direction. We're gonna rotate in the counterclockwise direction. It means that this is gonna be the mark 2, and this is gonna be the mark 3, and this is gonna be the mark 4, 5, and the 6th. Make sense? So here we start from the the right lower corner and rotate clockwise direction. Here we're gonna start from the top right corner, and we're gonna rotate counterclockwise direction. And then we're gonna draw vertical lines from these segments, from these marks, vertical line, from this one vertical line, from this one vertical line, and so on. Make sense? Then your objective is just to connect this segment 1, 2, and the segment 3, 6, and the segment 5, 4, right? Or 4, 5. Then from the midpoint of this segment, which it should be intersecting with the vertical axis, from this midpoint, and you're just gonna mark a point, this midpoint and this midpoint. From the first, you have to start with the segment 3, 6 first. From this midpoint, you're just gonna connect it to the 0 point. This is gonna give us the first line, the middle line. Then we're going to use this line as a reference to draw another line from this midpoint that it should be typically parallel to the middle line. Then from this midpoint, we're just going to draw another line that is typically parallel to this line in the middle. So we should end up with some intersections. Then your objective is just to locate a point, some points. This is definitely going to be one of the points, the start point. Then this segment, which should be set up between 1 and 2. It should be intersecting with line 1 and 2 in 2 points, right? So as you can see, since I'm not drawing with a scale, this segment, it had been intersecting with line 1 on the top there, but it shouldn't be on the top. It should be located within the drawing zone. So let us assume that it is located here. How about the segment 2? It is already intersecting with a point here. So this line, it should be intersecting with line 1 and 2 because this is segment 1 and 2. This one is segment 3 and 6. It should be intersecting with 3 in a point, with line 3 and line 6 in this point. Then 4 and 5, it should be intersecting with the 4 in a point, and 5, it should be intersecting with a 5 in another point. Assume that it should be here. Then your objective is just to connect these points with by hand. You're just gonna connect them by hand to end up with the cycloidal motion within the return period. Make sense? So this is the cycloidal motion in the rise period and in the return period, how we can graphically represent the thing. Again, this would require some practice to do it, but this is how we can use the graphical method to represent these different types of motions to represent the displacement diagram of the follower during the rise and the return periods. Make sense? All right, so now let us move to the last motion type of the follower, which is the modified uniform velocity motion. This is the updated one. This just to get rid of the difficulty or the challenge that we face for the uniform velocity motion, that when as we discussed in the previous video, in the uniform velocity motion, we gonna end up with acceleration that tends to infinity at the transition from the rise to the dual or from the dual to the return periods of the follower motion. So having this infinite acceleration, we said that it would damage the cam mechanism. So that's why we have to avoid this acceleration. And one of the approaches is just to depend on this, replace the conventional uniform velocity motion with the modified one. This modified one, I'm gonna represent it just to remind you with what we discussed in the previous meeting, like that this is the entire rise period of the follower. This rise period, it won't gonna be completely uniform as we discussed in the first method or the first type of the follower motion, but instead it's gonna have like kind of an accelerating period. It means that the velocity is going to smoothly increase. Then we're gonna have uniform period, another period that you're gonna have uniform velocity. The velocity is gonna be constant. Then you're gonna have a decelerating period that the velocity is going to decrease. So it means that the entire rise period, the entire beta for the rise event of the follower is going to be broken down into 3 sections. One section, the first one, we're gonna have acceleration, and in the middle we're gonna have uniform velocity. It means that the velocity is going to increase here, but here the velocity is going to be constant, but there the velocity is going to decrease. So that's why we're going to have deceleration in the third period. So we're going to have smooth transition starting from zero velocity, increasing the velocity smoothly up to the constant value, then keep going with the same velocity, then we're going to decrease the velocity up to zero smoothly. This will gonna give like a smooth transition. It is not actually 100% smooth transition to the dual motion or to the stationary state, but at least we won't gonna have infinite acceleration when we apply this type or consider this type of motion as modified uniform velocity motion for the follower. The same thing happens for the return period, and the return period should be also broken down. We start with like kind of accelerating, like with kind of accelerating in this way, then we're gonna have uniform velocity, then we're gonna have deceleration on the other side, right? So this third period, it's gonna be broken down into 3 periods as well. In the first period, we're gonna have deceleration, accelerating, it means that V is going to increase. Then in the middle, we're gonna have V is going to be constant. This is the uniform period. And then in the return, we're gonna have deceleration to decelerate to the zero velocity one more time. It means that the V should be decreasing. So how we can draw this combined? So this is like a hybrid type of motion that instead of working over just one period or one zone, which is beta and L, for the entire rise or return period, it's going to be broken down into different types of motion, 3 different types of motion. We do have acceleration with constant acceleration, and we do have deceleration period with constant deceleration value, and in the middle we do have a constant velocity with zero acceleration. The acceleration here, it should be 0. This one definitely is gonna be, as we discussed before, this one, it should be represented as parabolic motion. So the type of motion here, it should be parabolic motion, and in the middle it should be uniform motion, the conventional one, and here it should be parabolic motion. So how we can represent this or draw this type of hybrid motion between parabolic and uniform within the rise and the return period, this is what we are going to discuss, right? But information should be provided or given to us about the breakdown of the rise period or the entire return period. So for example, for how long in terms of the cam rotation do we have acceleration? The same thing, for how long do we have deceleration period, and for how long definitely we're going to have the uniform period. It means that this total beta of the rise, it should be broken down into beta 1, beta 2 and beta 3, three periods. So this beta 1 value, beta 2 value, beta 3 value, these three values should be given, should be provided to us. The same thing for the return period. Beta 1 it should be given, beta 2, beta 3, the length or the how many of the cam rotation, what is the angle of the cam rotation in which that this follower it should be accelerating, how what is the angle of rotation, how much for how long in terms of the angular displacement or angular rotation of the cam that this follower is going to move with constant velocity and so on for the deceleration. It means that how much is beta 1, beta 2 and beta 3 for either the return or the rise period or event of the follower. This information should be provided to us. But basically we do have two options, either that beta 1, beta 2, beta 3 already given to us, or instead he gonna give us the breakdown of these different motions over the y. And instead of giving us like this data over the beta axis, he would give us the breakdown. We can break down this period horizontally. Instead of breaking it vertically, we can do the breakdown of the rise motion of the follower in the horizontal direction. And in this case, he gonna give us this L1 and he gonna give us L2 and L3. So instead of giving you beta 1, beta 2, beta 3, I give you L1, L2 and L3. So it means that the breakdown of the rise period, the same thing would be applied for the return period. It would be given, the breakdown, it would be specified by a left or it would be specified by betas as already given. So I would give you either beta 1, beta 2, beta 3 or L1, L2, L3 to break down, to know exactly the breakdown of the acceleration, uniform velocity and the deceleration periods of the modified uniform motion. Make sense? So let us work in the beginning in case that assume that beta 1, beta 2, beta 3 already given to us, and we have to break down and generate the modified uniform motion graphically. This is what we are going to discuss first. Then I'm going to show you how we can deal in case that L1, L2, L3 are the one that given instead of beta 1, beta 2 and beta 3. Make sense? So beta 1, beta 2 and beta 3 should be given, and this is what we're going to consider. And remember that beta 1 it should be representing the acceleration period, and beta 2 it should be representing the zero acceleration period, and beta 3 is going to represent the deceleration period. And let us assume that beta 1 and beta 2 and beta 3 already given in such a way that the acceleration period is already given by which representing the beta 1 given for 30 degrees out of the 180. Remember that we assume that this beta for the rise is 180, but it would be different from one problem to the other. So let us assume that he tells us in the problem that the acceleration period takes only 30 degrees. Then the uniform period is going to take 120. Let us assume that this is 120 degrees. So 120 degrees in the middle, this is going to be uniform. This should be beta 2, and beta 3 is already given that definitely it should be the remaining, the rest. If you subtract 180 negative 30 negative 120, this is going to give us 30 degrees. It means that we're going to have, initially, we're going to start with acceleration for 30 degrees only out of the 180 and 120 degrees uniform motion. Then the last 30 degrees will be decelerating. So we have to break down the rise period, the rectangular zone of the rise event of the follower into three sections, three parts. So you're gonna measure 30 degrees, it means that you're just gonna measure 1 centimeter and draw vertical line. So this zone, it should be the zone for the accelerating event. Then we're gonna have 120 divided by 30, this is gonna give us 40. It means that you're just gonna measure 4 centimeters and draw another vertical line. Just you're gonna keep 1 centimeter at the end for the decelerating event. Make sense? So this is the first step. You just locate beta 1, beta 2, beta 3, how much they are, and break down the rise period. You're going to do the same for the return as I'm going to show you. Then what? Your objective is just to measure half of beta 1. How much is beta 1? It is 30 degrees. So half of it should be 15. And the 30 degrees in my scale, it is 1 centimeter. It means that your objective is just to measure half centimeter. Just half centimeter. You just gonna measure this distance here. And mark a point in the center. So this is beta 1 period, right? This should be beta 1 period. In half of the beta 1 period, mark a point. The same thing for the beta 3 period. In half of it, but at the end, near the end, this is the start point, remember, and this is the end point of the rise period, right? So from this midpoint, you're just gonna measure here, in this direction, beta 3 over 2, and you're just gonna measure in this direction, beta 1, this one, it should be beta 1 over 2. Make sense? Then your objective is just to connect this point to this point. If we connected, we're gonna end up with a straight line. This straight line is going to intersect with these two vertical lines that we just draw at 2 points. This is gonna give us the start and the end of the uniform motion. In the middle, we should have uniform motion, right? The uniform velocity motion. So we end up, automatically we got, this means that we already got the first curve, which is this one in the middle. This middle curve, this line, it should be representing the uniform motion in the middle. Now we have to work over the deceleration period and the accelerating period. We should have like a curve here for the acceleration, another curve here for the deceleration. But these curves, they should be parabolic functions or parabolic motions. So how we can generate this thing? We have to work or deal with this one like it is a parabolic motion, typically the same concept as we explained before. So this means that you're gonna spend more time and enough time to break down this period into 6 or 4 digits as we explained for the parabolic motion. Then you're gonna mark points, and then you're gonna connect the start point to the other point on the vertical axis until you're gonna end up with a curve. You're gonna repeat the same idea for the other side. But this it would take time, right? Especially for this case, for the case that I'm considering right now, it is not needed to spend all that time and break this very small zone, because the zone is very small zone in terms of width and height even. Like this period is too small even to break it down. So it is highly acceptable. It is totally acceptable if you just connected this point to this point with a curve that goes down. Like shows like it is kind of decelerating period. It is highly acceptable as long as this period it is too short or too small zone, as already shown here. The same thing for this one, I can connect this one with like a curve that already looking down or open down, indicating that this is a decelerating period. So we're gonna have another decelerating period and accelerating period, and you should understand that these two periods should be parabolic periods, accelerating and decelerating. So in case that these zones are too short or too small, don't spend time or waste time breaking down the zone and doing the same procedure as we explained for the parabolic functions up there. And instead just connect these 2 points with a curve. It's gonna be highly acceptable and you can proceed with that one. But in case that this width it is bigger, you have to break it down and you have to follow a similar approach as we explained on the top before for the parabolic function for this one and this one, which definitely would take time. Right? But for this course, and basically this is what conventionally happens. For this uniform motion, we are focusing more over the uniform period. So that's why the uniform period consumes the larger period or the wider period or the wider distance in comparison to the decelerating period or the accelerating period. So that's why it is highly acceptable, as I said, to just connect these two with a curve. Try to make a curve by hand is gonna be highly acceptable. Then you can move to the return motion. Make sense? So this is for the uniform motion in the rise period. Let us move to the return period. So remember that this is the start point, and again this is the end point. So we're gonna do the same. You should be provided some information regarding beta 1, beta 2 and beta 3, but for the return period. So let us assume for the return period that beta 1 is already, this one is the acceleration period is already for 30 degrees, and we do have the beta 2 which is the uniform motion is going to be for there, and beta 3 is already given, the decelerating period, it is already given for 30 degrees. So this should be definitely for 60 degrees as uniform motion in the middle, because this entire period is 120 degrees as we assumed in the above, right up there. So it means that you're gonna break it down into 1 centimeter on the left, another 1 centimeter on the right, and the middle is gonna be 2 centimeters representing the uniform motion. So we're gonna have 1 centimeter here, right? Then you're gonna draw this vertical line, another centimeter on the right, and this is gonna give us this 1 centimeter. This should be beta 1, and definitely this is gonna be beta 3, I'm sorry, and the middle is, it should be beta 2. Make sense? Then we're gonna do the same. What was the first step after drawing these two lines is just to mark a point at the midpoint of beta 1 and beta 3. So, but from the start, near the start, this is the start point. From the start point of the return, you're just gonna move to the left, because this is the way, this is the direction of drawing the curve. We're gonna move to the right, I'm sorry, and measure beta 1 over 2. The midpoint, and mark a point. Then do the same near the end point. Next to the end point, you're just gonna measure this way, beta 3 over 2. Then you're gonna mark a point. Then your objective is just to connect these 2 points, these 2 midpoints together. You're gonna end up with a line that is going to intersect with the vertical line in 2 points. Then this automatically gonna give us the first line, which it should be the uniform motion line in the middle, as already represented here. This one is gonna be just connect this point to this point. This is gonna give us the uniform motion in the middle. And how about the accelerating period? Just connected by hand, because this is a very short period and this thing is a very short period as well. So it is highly acceptable to have this acceleration and decelerating period to end up with the uniform velocity, modified uniform velocity motion. Make sense? So this is simply how we can represent the modified motion for the rise and the return events of the follower, in case that he give us beta 1, or the breakdown of this uniform motion in terms of the acceleration, deceleration, and the zero acceleration events in terms of betas. Like we already breaking down this period of the rise and the return in terms of beta 1, beta 2, and beta 3 already given. How about in the other way? How about if L1 and L2 and L3 are the ones that already given to us, not beta 1 and beta 2 and beta 3? So it's gonna be very simple approach, and it's gonna be very simple thing to do. So now let us assume that the total lift is already given by 60 millimeter, and the acceleration period is already given for, like, in terms of the displacement of the follower, as let's say 10 millimeter out of the 60 for as accelerating period. Then the uniform period, it is for 40 millimeter, and the decelerating period, it is just for 10 millimeter as well on the other side. So this sum, it should equal to the total lift. It means that we have to break down, but we're gonna break down this zone horizontally, not vertically as we did before. There he gave us beta 1, beta 2, and beta 3, but now he gave us like L1 and L2 for the uniform, and L3. This is for the accelerating, the uniform, or the zero acceleration, and the decelerating period, right? So we're gonna break it down horizontally. So we're just gonna measure the L1, which is the first 1 centimeter. Just measure 1 centimeter and draw dash line horizontal. So this is gonna give us the accelerating zone. Then we're gonna measure another. So this is the first period. Then the second period, we're just gonna measure another L2, which should be 4 centimeters, as already given down there. It is 40 millimeters, so it should be 4 centimeters. And then you're gonna draw another horizontal line in this way. Make sense? So this is gonna be the decelerating period, which it should be L3. Then what? Once we draw these things, what we did here, we defined the midpoint of the beta 1 and the beta 3 at the next to the start point and next to the end point. But here we just gonna draw a line going down. We just gonna draw another line, very light line, very thin line, like this one, going down in this direction. The length of this line, it should equal to the L1, because this is the start point, right? So it should equal to the L1, which is for the accelerating period. So you're just gonna go down with L1, then you're gonna mark a point. Then you're gonna do the same, but next to the end point. This is the start point. Next to the end point, you're just gonna do the same. You're just gonna go up with L3, but you're gonna go up this height, it should equal to the L3, the third point. Then you're gonna mark another point. Then your objective is just to connect these 2 points together. You're just gonna connect this point to this point. So you're gonna end up with a straight line. This straight line is going to intersect with the 2 horizontal lines in 2 points, right? It's going to intersect with the 2 lines in 2 points. If you connect these 2 points together, you're gonna end up with the uniform motion in the middle. If you're just gonna connect these 2 points together, this is gonna give us the uniform motion. The rest, as you can see, we're gonna end up with a zone for the parabolic motion. We're gonna end up with this zone, this one, for the accelerating parabolic motion, and we're gonna end up with this zone for the decelerating parabolic motion. But these zones are big, kind of big. They are not small to just connect them by hand. So what does it mean? It means that we have to break it down. We have to break this zone as we did, and we'll try to apply an approach as we did before for the parabolic motion. So I'm gonna explain it very quick to you, but I'll do my best to not include this thing in any of the exams because it's gonna take time, or at least in case that I decided to give you any uniform motion, so at least I'm gonna give you the uniform motion in such a way that make this zone, it is very short, to represent it as so you can connect by hand directly. But for this one, it is kind of long or wide zone, so it is preferred or it is recommended to represent with more accuracy the parabolic motion for the accelerating period and the decelerating period. So I'm gonna show you very quick how we can do it for over this zone, which is this one. So you're gonna deal with this one like this is your beta for the parabolic, and this is the L for this zone. Just focus like this. Assume that this is the entire rise as we did before for the parabolic motion. But this parabolic motion is gonna be a little bit different than what we explained on the top before. So what you're gonna do, your objective is just to break down this zone into 6 digits or 4 digits or 4 segments. Let us break it down into 4. So your objective is just to measure this length and divide this length in terms of centimeter. You're gonna divide it by 4. So we're gonna break it down into 1 segment and second and third and fourth. Then you're gonna draw from these segments vertical lines in this way. So this is gonna be the 0 because we start from here. This is gonna be 1 and 2, 3 and 4. Make sense? Then over this vertical line in the parabolic motion and on the top there, we picked the line in the middle. No, don't choose the line in the middle. Don't do the division over the line in the middle. Do the division over the last line at the end, because we needed all the entire zone should be accelerating only. But there we were breaking down the zone, the rise zone or the return zone, into acceleration then deceleration, right? But here we needed all is acceleration, and we needed here all of it decelerating motion. Make sense? So what does it mean? It means that we have to do the division over this vertical line. So we're gonna divide this line, vertical line, also 4 digits in this way, 4 segments. So this is gonna be the 0, 1 because we're already rising. This is gonna be 1 dash. This is 0 dash and 1 dash and 2 dash, 3 dash and 4 dash. Make sense? Then what your objective is just to connect. Your objective is just to connect the 0. This is the start point. You're just gonna connect the start point with all of these vertical points. So you're gonna connect the 0 with the 0 dash. You're gonna end up with this horizontal line, and the 0 with the 1 dash, the 0 with the 2 dash, with the 3 dash, with the 4 dash, and so on. So we're gonna end up with some lines that already intersecting with these vertical lines in some points. So then you're gonna locate some points. The intersection of 1 dash with 1, this is gonna give us a point. The intersection of 2 dash with 2 gonna give us another point. The intersection of 3 dash with 3 gonna give us a point. And then the intersection of 4 with 4 dash is gonna give us a point. Then if you just connected these points together, you shall end up with the curve. We're gonna end up with this curve. Let me create the thickness of the line so it's gonna be clear. We're gonna end up with this line, this curve. It should equal to, or this is the accelerating period. Then we're gonna repeat the same thing, the same idea for the other side. for the decelerating period in this way. So we're gonna do the same for the decelerating period, starting from the end point. This is the end point of the rise. So we're gonna consider this is like our 0 point. This is the start point, kind of, although it is the end, but it is the end for the rise. So I'm gonna start from this point. This is gonna be my 0 point. Then I'm gonna break this period into 4 digits, as I did there. Then I'm gonna draw vertical lines in this way, like these light vertical lines. This is gonna be like 1, this is 2, 3, and 4. Then over the last line, the last line, which is the 4th one, I'm gonna break it down also into 4 digits. This is gonna be like the 0 dash, and we're gonna have the 1 dash, the 2 dash, the 3 dash, and the 4 dash. Make sense? Then we're gonna do the same. We're just gonna connect the 0 point to the other points on the vertical line. So we're gonna connect the 0 to the 0 dash, and the 0 to the 1 dash, the 0 to the 2 dash, the 0 to the 3 dash, and the 0 to the 4 dash. So we're gonna end up with some intersections. You're gonna find that 1 intersects with 1 dash at this point, 2 intersects with 2 dash at this point, 3 intersects with this 3 dash at this point, and another point for the 4 and 4 dash. Then your objective is just to connect these points. You're gonna end up with the decelerating period for the parabolic motion for this period. So if you just connect them, you're gonna end up with the deceleration. In the middle, we're gonna have the accelerating period, and this is gonna be this is the 0 acceleration, this is the acceleration, and this is the deceleration period. This is the modified uniform motion for this rise. Why I did break this one into, or divided this one into different segments, and I didn't do up there because simply this zone is very small, very narrowed zone to represent or to do the division. So it is acceptable if you connect it here, but for this one it is wider zone, so we have to break it down. We have to divide it into different segments and follow the approach as I explained for representing this parabolic motion in the accelerating period and the decelerating period. Make sense? So this is for the uniform motion, and we can repeat the same for the return motion by measuring L1. The key idea here, in case that L1 and L2 and L3 already given to you, you just gonna move down with L1 and you're gonna jump up from the start and the end point with L1 and L2 to locate point. Then you're gonna connect these 2 points together with a line. This line is going to intersect with the horizontal line at 2 points to end up with the uniform motion. Then you're gonna work over the parabolic motions at the 2 ends. Make sense? We can repeat the same approach over the return motion. So if we decided to work over it, so it's gonna be typically the same approach. So this is how we can graphically. This is the main objective of this video today, is just to show you how we can, all of this procedure. So you have to practice these things, and how you have to try it by hand, right? At home and in the homework. So this is very important to try these things by hand, so you could able to practice how you can generate these different types of the follower motion and represent this displacement diagram for the follower motion, because we need it, because you have to generate this graph in very accurate, because you're gonna use it after that to come up with the profile of the cam, and this is what we are going to discuss in the next video, right? So but for this video, the objective, as I said, is just to show you how we can represent these different types of motion graphically, and to explain these procedures as we did through this video. The next video, as I mentioned, we're gonna work over the cam profile, how we can, starting from a displacement diagram, how we can extract the cam profile. We're gonna start from this one, assuming that it is already given to us, and the objective is just to come up with the cam profile that achieves this type of motion. Also, we're gonna come up with this profile graphically as we did for the displacement diagram. So thank you, and that's it for this video, and thank you, and see you in another video.